solubility. Oh, let me turn this thing on. We talked about solubility a long time ago. We talked about it. We were saying, can things dissolve in something? We talked about aqueous solutions. But solubility means it's the ability of a substance to dissolve in water. If something can dissolve in water, it is soluble. If it can't dissolve in water, it is insoluble. Okay? And if it can dissolve in water, we say it is aqueous when it's in the watery solution. Okay? So when it's in that watery solution, it is aqueous. Close this door. Okay. Basically, this slide shows you how things dissolve. Things dissolve. Give me 1 second. Things dissolve when water molecules are attracted to one of the ions that in it, one or more of the ions. This is the salt crystal in here. And these little Mickey Mouse looking things, so these are the water molecules. So here's my salt crystal. The water goes down and bumps into one of the ions, and it kind of draws it away. The hydrogens, which are positive, will go towards the negative ion and drag it away. And then the oxygen, which is negative, will go towards the positive ion and drag it away. And then they surround them. And they keep them suspended in solution. So they're aqueous. So they look like they disappeared, but they didn't. They're just in the water. This is a quick little clip that shows you how dissolving occurs.
When an ionic substance, such as sodium chloride, is placed in water, water molecules interact with the ions on the surface. If the salt is soluble, the attractive interactions with water molecules overcome the ionic attractions within the lattice. The solvated ions move off the surface and become separated in solution. Notice that water molecules cluster about the anions with the hydrogens directed toward the negatively charged ion. On the other hand, water molecules interact with the positively charged cations through the lone pairs of electrons on the oxygens.
Okay, so basically they just get attracted to the water molecule and they go away with it. Now, if you get your periodic tables, please. Okay, now I'm going to show you how to read the solubility table. You have to know how to read it in order to move forward. The solubility table will show you how to predict products for a double replacement reaction. Okay, so you use these for your double replacement reactions. So somewhere near this chart, write for double replacement reactions only. Okay, you use the activity series for single replacements. You use this solubility table for double replacement reactions. Okay? So if you look up here, the green area shows you one thing, and this like rusty orange color shows you another. We group them like this. Like if I had said, okay guys, everyone can go to Taste of Ross unless you failed the class. Because it'd be easier for me to say that because so few of you failed the class. It'd be easier for me to say everyone goes except for those of you who have an F. If not, I'd have to say, Logan, you can go. Isaiah, you can go. Lexi, you can go. Why say all of them when I can just group you in a big group and say everyone goes except? Because there's fewer people who are except than those are who are going to go. Does that make sense? Same thing here. So all of these are soluble except these. So all group 1 metals. Griffin, will you show us what the group 1 metals are? on the periodic table behind you. Will you show us where they are? Stand up and show us the group 1 metals. Any metal, there you go, any metal in that group will always dissolve in water, no matter what anion it's with. Okay? So I could have sodium dichromate, which typically doesn't dissolve. It will still dissolve. I could have ammonium oxalate. It's going to dissolve. Okay? So any group 1 metal or ammonium will always dissolve. No exception. Just ma'am.
Hydrogen's not a metal, but does that count?
No. It's, oh, thank you so much. Lynn. Hydrogens will always be aqueous. So I guess maybe it kind of does fall in that same category. Very few hydrogens are not. But they kind of do other things though. But yeah. Yes, sir.
How do you know about like ammonium?
How do I know about ammonium? You just have to know it. Yeah, one of those things. It's the only positive polyatomic ion. So it acts like a type 1 metal. It acts like a group 1 metal. So it's got a +1 charge to it. Okay? Now nitrates. Notice how all the other ones are anions. So anything with a nitrate or an acetate will always dissolve, no matter what. I could have lead 4 nitrate. It's going to dissolve in water. I don't care what you put with nitrates, they always dissolve. Okay? Now, here's where it starts getting wonky. Chlorine, bromine, and iodine are all soluble, no matter what, unless they're with silver, lead 2, or mercury 1. So I could have lead 4 iodide and it would be soluble in water, but lead 2 iodide is not. Does that make sense? So you have to look at the exceptions over here. And sulfates are all insoluble except these 6. So calcium sulfate will not dissolve in water. Strontium sulfate will not dissolve in water. Does that make sense? But mercury 2 sulfate will. Gold 1 sulfate will. Just none of these. Does that make sense? Now, down here, these are all insoluble except for these. These are always going to be solids, a precipitate. So if I have any carbonate, sulfite, phosphate, and chromate, they're always going to be a solid. They will not dissolve in water unless they're a group 1 metal and ammonium again. Okay? Hydroxides were all insoluble unless they're group 1 metals, ammonium. Calcium and barium are slightly soluble. They don't dissolve a lot, but they will dissolve a little. So the water is going to be cloudy. Sulfides, group 1 and group 2 metals, and ammonium. And oxides look just like hydroxides. But you have to be able to read this table and be able to tell me if something is soluble or insoluble. You good? Let's try that. Let's see if I can just pause. Oh, I can't pause it on here. Well, let me pause it. No.